Hi everyone, welcome to Postgres Google Hangout. This is Shreyas Deshmukh from Ashnik. We are an open source solutions provider with presence across Southeast Asia, US, UK, and India. We provide Postgres services, database solutions, and training across these regions. We are also the master partner of Enterprise DB in Southeast Asia. In today's Postgres Google Hangout, we are going to talk about tuning the memory and optimizer parameters. Samir, who is Ashnik's database solution architect, would be giving you a detailed insight about this topic. We hope you guys would enjoy this. Over to you, Samir.
Hello. Hi everyone. We had been getting quite a few requests and feedback regarding memory parameters and optimizer parameters to be included in one of our hangouts. So this time we decided to start with PostgreSQL parameter tuning, and to begin with we have picked up one of the most requested topics, memory and optimizer parameters. So let us begin with this, and I hope by the end of this session you guys would have learned quite a few things about how to tune your parameters. Before we begin about which parameters and what values, let us first understand how PostgreSQL works in the backend. What things are moving in the internals or in the backend of PostgreSQL. Once you have understood these things, it becomes quite easier for you to understand and appreciate the value and importance of the parameters that we will be discussing today. So in PostgreSQL, there is a postmaster process, which is like init process of Linux. This process owns all the other user and utility processes like AutoVacuum, stats collector, checkpointer, wall writer, as well as the connections which are made to the PostgreSQL. In the memory component, there is a shared memory defined for postmaster process. In this shared memory, you have shared buffer, which stores the cached blocks or the cached pages from the tables and indexes. The data is read from data files into file system cache and then put inside shared buffer. There is a memory segment called wall buffers, which caches basically the wall records, and as soon as these wall records are filled, or as soon as you commit your transaction, these wall buffers are flushed to the file system cache and then flushed to the wall files on the disk. There are temporary files which are used for sorting, and in addition to having temporary files, to speed up the sort process, there is a sorting space in the memory which is called work memory. There is a separate segment used for maintenance work like indexing or creation of foreign keys. This area is called maintenance memory or maintenance work memory. Now, how things work is data is cached into shared buffer and then data is returned to users from shared buffers. So let us go to the next slide where we will be discussing about configurations and how it is edited. So PostgreSQL.conf is the place where Postgres places all the configuration or all the parameters. It is generally located inside your data directory, and each line in this file has a parameter. This is stored in a key value pair format, which is separated by an equal to, like you will have something like shared buffer equal to some value. So shared buffer is the parameter, and the thing which is after, or the integer value which is after or on the right hand side of your equal to, is the value for that parameter. You can also set some parameters on the command line when you start up your PostgreSQL database using pgctl. You can also include your parameters in a different parameter file and then use include directive to include those files in PostgreSQL.conf. So this becomes quite handy. You can have a common file for for tuning most common parameters for all your instances, and then you need to just transfer that file and add one line in PostgreSQL.conf. it makes your life quite easier. Well, let's see what other places where you can edit the values. You can make changes into the configuration not just at instance level but also at database level using alter database command. This way, if you have got multiple databases in your cluster, you can choose parameter values for certain parameters according to the nature of that database. Let's say if you're dealing with an OLAP database which does quite extensive sorting, you can keep work mem quite high. Or you may want to enable more granular logging for a particular database or for a particular user. You can also use alter user command to set these parameters for a particular user. Further, you can change parameter values at a particular session or within a transaction. So if you have got a more costly query, you can allocate more resources by setting a much higher work memory within that session. This makes your operations quite flexible, so you do not have to allocate very high memory at global level, but at the same time queries which needs high amount of resources can make use of this particular facility. But remember, not all parameters can be changed at session level. For example, shared memory or shared buffers or wall buffers. These parameters can only be changed inside PostgreSQL.conf, or you can change them on startup. In version 9.4, there will be an alter system command. This command can be used to modify the values via SQL statement as well. So that makes life of a DBA much more easier and simpler. But that is going to come only in 9.4. Now let us look at some of the parameters. So the first section would be on memory parameters. Let us explore some memory parameters which are important for you. Shared buffer, as the name suggests, this is the size of the shared buffer for your database instance. The default value is quite small, and it is not enough for even for the simpler databases or even for most of the common production usage. So it's highly suggested that you change this value. Generally, depending on the size of RAM and nature of database, you can keep this value from 15 to 30% of the total available RAM. In certain cases, keeping this to 40% also could be beneficial, but something beyond that, or in most of the cases something above 8 GB or 10 GB is not very practical or is not going to be very beneficial. And this is primarily because PostgreSQL also relies on file system caching. So if something is not found in shared buffer, there are high chances that it would be found in the file system cache. That is why keeping a very high value for shared buffer is not very helpful all the time. If you are having a shared server where you use multiple database instances, or you're running multiple servers, or you're running multiple applications along with the database, you should at least keep this to be high enough to accommodate your indexes so that you can benefit from, you don't have to suffer from page miss for index pages at least. Remember that if you're using a 32-bit instance or a 32-bit machine, even if you keep this value above 2 GB, it will not be very helpful because there are some inherent limitations with 32-bit architecture itself. Not that PostgreSQL has it, but your OS and the way the 32-bit architecture maps memory has its own inherent limitations. That is why keeping something above 2 GB on a 32-bit setup is not very practical or recommended. If you're using something below version 9.2 or 9.2 for PostgreSQL, you need to set your SHM max parameter at OS kernel level as well before you can increase shared buffer. This is required, but in 9.3 this has been changed. The way memory allocation happens has been changed in version 9.3, so you don't need to do that in 9.3, or even when 9.4 comes out, you would not have to do that on 9.4 either. Second memory parameter that we will be discussing is work memory. This is sorting memory. This is the allocation in your shared memory where sorting happens. So whenever a statement requires to do a sorting operation, a chunk of memory which is equivalent to work mem will be allocated. Of course, if you keep this value high enough, sorts will be done in memory and they will be fast. What you can do is you can log your temp file creations by setting this parameter log temp files, in which case if sorts are going to disk, they will be logged. Or if you think that there is a query which is running slow because of the sorting issue, you can set that, you can see that by doing an explain plan. So in explain plan you will see a node which says sort method equal to external merge disk, and it will define how much amount of space was used on disk for this sorting. You should either try to set this to be a high enough value which enables a in-memory sort, in which case quick sort will be used. But in certain cases quick sort can take quite a lot of memory, and in those cases you should set it to at least to the amount of memory which is being taken on the disk for an external sort. So in our case, let's say if x KB was used for merge sort on the disk, you should at least allocate x KBs or x kilobytes for work memory. Remember that this is allocated for each sorting operation and not just for each statement or each session. If your statement involves 8 tables and it does a sort on 8 tables, 8 such blocks or 8 blocks of work memory will be allocated. So if you have kept your work memory to 50 MB, you will end up spending somewhere around 400 MB just for one statement execution. And if you have such 10 such statements executing, you will end up spending 4 GB of your memory on just work memory allocations. So it is not a very good idea to set a very high value at the instance level. Instead, you should set a moderate value which serves most of your statements at instance level, and then change this value at database or user level, or more appropriately or more better way of setting it is to set it at session level just before a costly query, and then reset it back. This way that allocation will be deallocated once that statement processing completes. So this is the most efficient way of setting work memory. Temp buffers is the memory segment which is used for caching temporary tables. This can be changed at the session level, but if you're changing this at session level, remember to change it before you create your first temporary table. If you're changing it after creating a temporary table, that change will not be effective in that session. You should remember that this particular cache area is used only if you're using any temporary tables. So if you're not using any temporary tables in your application, you don't have to worry about setting temp buffer. Even if you set this to be a higher value, temp buffer will not be allocated to that much amount initially. It will only be allocated as needed, and it will incur a cost of 64 bytes for each allocation. And if that allocation is used, it will use another 8 kilobytes. So this is not a very huge overhead or a very huge cost. So if you are using temporary tables, you can set this to be a higher value. And again, this is per session. Maintenance work memory. This helps improve performance of maintenance operations like we discussed, vacuum or create index or alter table, add foreign key, or even auto vacuum operations. Those operations can significantly improve their performance if you set this to be a higher value. Now, a good value would be large enough to hold your tables for reindexing or creation of indexes or vacuuming operations. On a system which has got something around 64 GB of RAM, you can set this to 2 GB, or in certain cases even to 4 GB. If you don't have high need for work memory, then you can set this to be something around 4 GB or 5 GB as well, so that operations which involve vacuuming or which involve indexing can be performed much more faster. Remember that you will not have too many sessions which are doing maintenance operations. You will only have fewer such operations which do maintenance. So you can set this to be a higher value compared to work mem. And if you have multiple threads defined for auto vacuum, which you can define by max auto vacuum worker, each of them will consume one slot of maintenance work mem. So keep that in mind when you're setting value for work mem. You should also consider what value you have set for max auto vacuum worker. If you set this to 2 GB and your max auto vacuum worker is 10, you may end up spending 20 GB just for maintenance work mem. So set that appropriately according to that. Now let us shift to next set of parameters which are for query planner or which are for optimizer. Let us understand few things about these parameters which I have seen people tend to forget while tuning these parameters. These parameters are just an input to your optimizer. They help your optimizer decide the best plan. They do not define the actual allocation of memory, or they do not define how fast your disk will be performing. Your disk will perform at its own speed, but certain parameters will provide an input to the optimizer on how fast is your disk. If you set this parameter to a lower value, that does not mean that your disk will start performing slower. So they do not decide the actual hardware performance. They are just an estimate or measure of that hardware value or that hardware, let's say in case of effective cache size, it is just an estimate of memory, or in case of random page access cost, is just the cost of accessing random pages, an estimate of that. So the first parameter in this is random page cost. This is the cost of accessing a random page on your disk. The default is 4.0, which is quite conservative in my opinion. A larger value means that your index scans are going to be more costly, because index scans will need random access of pages, and that is why if you set this value to a lesser value, optimizer will be pushed to choose an index scan over a table scan. A good value for most of the modern disks could be 2.0, 2.5 or 3.0. If you're using flash disk or solid state disk, you can choose a value 1.5 or 1.8. In certain environments, I have seen that there is hardly any difference in random page access and sequential page access, and I have seen DBAs setting this value to be 1.2 or 1.1, and that works quite well for them. Remember that as I discussed earlier, this is not a definition of how Postgres will access random pages. Postgres will always request OS to access pages, and this only defines how fast Postgres can expect. It is not how fast Postgres will access pages, but only the expectation of PostgreSQL. Now, this is something which you should look at only at the end. Generally, the problem, if you see that you don't have too many index scans and your optimizer is choosing more table scans rather than index scans, the first thing that you should look at is effective cache size, which we are going to discuss in one of the next slides. Sequential page cost. This defines how fast your Postgres can expect requests for sequential pages to be fulfilled, which means how fast tables can be scanned on their own. general value is 1.0. You may want to change this to reduce the indicative cost based on caching. For faster disks, you can even set it to zero point 0.8 or zero point 0.9. And as a general practice or as a good thing, you should always keep this lower than random page cost. In some cases, you may want to set it equal to random page cost. In certain cases, that works fine as well, like 0.8 for random page cost and 0.8 for sequential page cost. Effective cache size, like I mentioned earlier, PostgreSQL relies quite a lot on file system caching. And this parameter helps optimizer envisage how much amount of memory is available for caching the files. And this is of great importance when optimizer is considering index scans. Unless your pages can fit into the file system cache, your optimizer may not choose index scans. And in that case, the reason is your effective cache size is not large enough. It is not that your actual cache allocation is smaller, because that is defined or decided by the OS file system. But it is just that you have not indicated that in a proper way to your PostgreSQL process. A good value generally could be 50 or 80% of, could be anything between 50 or 80% of your total available RAM on the dedicated servers. If you're using a shared server, you may want to look at OS statistics. You can use free command on Linux, or you can use the task manager on Windows and look at free plus the cached memory to arrive at a proper value for this parameter. On Windows, you can see the cached memory. I think it is cached memory on Windows, which you can see in task manager, and allocate this value accordingly. Remember that this value is not an allocation of memory. It is not like shared buffer. Shared buffer is something where you allocate memory, where PostgreSQL takes that much amount of memory. This is just an indication. And generally, tuning this parameter has as good benefit as you will have with shared buffer, or in certain cases, it is better than that. So tune this parameter well enough when you're starting a new instance or when you're installing a new instance. A higher value, like we discussed, is more likely to promote index scans. There are some enable underscore parameters in PostgreSQL.conf. You can change these parameters at instance level, or you can change them at session level as well. Generally, these are used to tell optimizer whether you want to include particular optimization techniques or not, like whether you want to use index only scans or not. So if you set it off, enable underscore index only scans, if you set that particular parameter off, index only scans will not be used. It is always wise to leave them to default. You can change them for specific queries, like I mentioned. Try not to change them at the instance level. And remember, these are not hints. This is not like the hint concept or the or something like where you indicate or where you input a particular choice of optimization technique to your optimizer, and your optimizer can overrule that. This is something which will be respected by the optimizer. It will not discourage usage of a particular optimization technique, but it will rather not use that technique if it is set to off. So do not set it off unless you think that it is really needed and it is going to help you for a particular query. With an exception, enable materialization cannot be completely suppressed. That particular operation or materialization technique may only be discouraged in PostgreSQL optimizer. If optimizer sees that it is needed, it will still use it. But all other things like index only scans, index scans, or bitmap scans cannot be suppressed completely. Can be suppressed completely by setting it off. So Be sure when you're setting them off, especially when you're setting them off at global or instance level. In my opinion, you should never do that. So these were some of the parameters which we found, which I thought and we have found from our own experience are useful for tuning the performance of PostgreSQL. We'll be sharing more things going ahead in future. If you're interested in looking at some of our previous hangouts which are related to streaming replication or table partitioning or query tuning in general, please go and look at that on our YouTube channel, Ashnik Biz. Here is our contact details. Reach out to us if you have any suggestions, questions, or feedback. Thanks a lot. Now let me go back and check if we have got any questions. So I'm gonna stop sharing my screen. So Nitesh has a question here: whether include directive in PostgreSQL.conf, whether it is an whether that causes an increased overhead. So not really, Nitesh, and it is not really an overhead. It is in fact quite a flexibility given by PostgreSQL. It is not an overhead at all. I use that quite often for tuning my parameters. I use that quite often even when I have to set replication. So I keep all the replication parameters in a different file. Or even when I have to set archiving, it makes my life quite easier. Let me see if there are any more questions. So no, we don't have other questions. So if you are watching us live or if you are watching a recording of this video, feel free to drop us a question via email, or if you'd like us to discuss any other topic, please drop us a note via email or comment on the YouTube or Google Plus page of this event, and we will try our best to include those topics or cover those topics, and we'll try our best to answer your questions as well. Thanks a lot. Thanks for joining. I hope you all learned something good in today's session, and we'll be back very soon. Thank you. Yeah.